things and we'll get things moving. Sound good? So what's the, which Jocelyn are you again? I want to call you Kate and I want to call you Bridget. Neither one of those are correct. Gabby. Gosh.
Can you do like one of like a question like the second question?
Okay. So that was something that was like in this form, right?
Yeah.
So maybe something that looked kind of like this. So when we're in this form, the key thing that we needed to remember was how to find the vertical and horizontal asymptotes. So the vertical asymptote is going to be negative d over c, and the horizontal asymptote is going to be a over c. So in our case, that's going to be negative of negative 4 over 2, which is just 2. And then our horizontal asymptote is going to be 5 over 2, or 2.5. We're doing some questions, but we'll pass things out after we're done with the questions. If you guys want to just like grab a desk on the side, you're welcome to do that. And that probably are able to distance yourselves enough to where that's going to be okay. Does that feel all right with you guys?
Yeah.
Okay. Again, let me know if you don't, if that doesn't work or whatever, or if you need to move around a little bit so you can see or whatever. It's cool with me. Whatever you need to do to feel like you're following your coach's directions. Okay? All right. Anyways, Gabby, you feel good there? Okay. So once we've identified that, we can do the domain and range. Remember, the domain is everything except for the vertical, and the range is everything except for the horizontal. Right? Everybody's good with that? And then we'll make our XY table. So the middle value needs to be the vertical asymptote. So I'm going to pick 3 values that are less than the vertical asymptote and 3 values that are bigger. It doesn't really matter what those 3 values are. I'm usually going to pick whole numbers right in a row just because it makes the arithmetic a little bit easier. And now to find these values for y, what I'm going to do, say to find this value of y, I'm going to take this value of x and plug it into the x's in the problem and evaluate. Now, if you're doing this in your head, you'd have like negative 5 plus 3, so negative 2, and then 2 times negative 1 minus 5, so negative 6. So you'd have like negative 2 over negative 6, which is 1/3. Now, probably most of us aren't comfortable kind of carrying that much in our head and doing that much in our head, and that's okay. Well, we can also use our calculator to do this. So the easiest way to do that is using the fraction command. So if I press alpha and y equals, that opens up the fractions menu. The first option there, numerator over denominator, is the one that you'd want to use. And then I'm going to type in exactly what I have here, but instead of x's, I'm going to put in this case, negative 1. So 5 times negative 1 plus 3. Make sure you use the negative sign instead of the subtraction symbol. And then 2 times negative 1 minus 4. Make sure you use the subtraction symbol and not the negative symbol. And then I'm going to move my cursor outside of my fraction, and I'm going to retrieve the decimal command so that my calculator will list this as a decimal. To do that, I press the math button, and I'm just going to choose that decimal command there, and then press enter. So there's my first y value. Now to get my next y value, I'm going to just recall this same input and update it. So I'm going to change the negative 1s to 0s. So I'll press second and enter, That'll give me the exact same thing I just typed in. And then change the -1 to a 0. And then press enter again. And I can continue kind of just doing this indefinitely, right? Yeah, that was alpha and then the y equals button. So alpha is the green one and y equals is in that top left-hand corner. And I can just kind of keep doing this, right? In the interest of time, I don't really feel like I probably need to finish plugging these in over and over and over again. That's probably enough for us, right? The one thing I'd caution you again, remember vertical asymptotes are the ones that go up and down. Horizontal is left and right. And if what you're plotting doesn't really make sense, the likely problem is that you goofed up on the vertical asymptote and goofed a negative sign or something on it. Kate? Emma? God, what is the matter with me?
How does the graph kind of cross each other?
Yeah, so the two lines that you're going to see are the vertical asymptote at 2 and the horizontal asymptote at 2.5. And then, like, I'd plot this half of the graph. So -1 and 0.3 would be like here. 0 and 0.75 is maybe down there. And then 1, -4 is there. So we just have something that kind of looks like that. And then the other 3 points will be like up here somewhere. Is that good? Reese? We can try. So it's hard to come up with an example where that happens right off the top of my head, but I can try here. Jack? So that's the vertical and horizontal asymptotes. So the vertical asymptote was at 2. So that's the vertical line at 2. And the horizontal asymptote is 2.5, so that's the horizontal line at 2.5. Is that okay? Groots? Either is fine. I don't know why you'd pick decimals if you didn't have to, but you can use decimals. It's not wrong. Yep. Okay. Reese, you said you wanted to see something where we have a horizontal or a extraneous solution. So that's going to be a solving type problem. Give me a minute to kind of think one through here. So don't write anything down until I tell you to, because I'm going to probably goof something up while I'm trying to come up with one that has an extraneous solution in it real quick. Let's do 4. That's going to give me square plus 3x, and that's going to give me 4x plus 8. And then if I move all this, that's a 7x. So I'll put it all over here. Let's have that need to be so we need like a minus 9x there. Okay. I think that'll work. Let's try it. I reserve the right to come back and alter this a little bit to make it work out the way I want it to. I think I got that. Okay. So this is a solving problem, right? So the two techniques we have for dealing with a solving problem is to cross multiply or clear fractions. We can't use cross multiplication in this case because we don't have a proportion, because the one side we have two fractions added together. A proportion, you have to have just one fraction equal to one other fraction. So I'm going to use the clearing fractions technique here. So I'm going to start by factoring everything that I can. Well, the only piece that's going to factor is the x squared plus 5x plus 6. The two numbers that multiply to give us 6 and add to give us 5 are 2 and 3. So from there, it should be easy to see that that least common denominator is going to be x plus 2 times x plus 3. Is everybody okay to hear? Reese, you happy so far? So what I'll do now is I'm going to multiply both sides of my equation by the least common denominator. So when I multiply it to the right hand or the left hand side, I have this, and when I multiply it, I get that LCD times the first fraction plus the LCD times the second fraction. Is everybody still okay with what I have there? Basically, we just multiplied the LCD by every fraction in our problem, right? So now I'm going to do these multiplications. But really, I'm just going to be reducing, right? The point of multiplying by the LCD is so that there's a lot of reducing that we can do. So when I multiply that first pair together, I just get negative 9x. When I multiply the second pair together, I get x times x plus 3. And when I multiply the second, or the last pair together, I get 4 times x plus 2. Are we all okay with what I did to get to there? Okay. What I'm going to do now is I have like a polynomial equation, right? Because I got rid of all the fractions, which is fantastic. So I'm going to just multiply everything out. So in this case, that just means distributing. And when I combine like terms on that side, I get that. And I'm going to go ahead and make a change here. As I warned you, I was probably going to have to. I just want that to be positive 9. So to solve this quadratic, I got to get everything onto one side. Oh, fiddlesticks. Boogers for breakfast. I goofed this up. What do I need to do? Ugh, this is going to be a nightmare. All right, so this, I guess, needed to be subtraction. Nope. Let's just make, I guess it doesn't matter. That needed to be subtraction. So that's going to change there and there and there. I warned you, Reese. So that's just going to be negative 1x minus 8. And then this 9x really just needed to be x. Okay. There. Now I think it's done what I needed it to do. Sorry about all of that, but you asked for something with an extraneous solution. Those are hard to come up with just on the fly. So this now is a quadratic, right? To solve this, we can either try to factor this, or we can use the quadratic formula. I notice that this is factorable, so let's just factor it. Multiplies to give us -8, and adds to give us -2 is -4 and +2. So my solutions there are 4 and -2. Now to check for my extraneous solution, what I'm going to do is I'm going to take each answer. So I'm going to start with the -4. And I'm going to go back to the original equation and plug that in for x into the denominators and see if any of them give me a 0. So if I plug 4 in, obviously 4 plus 2 isn't 0, and 4 plus 3 isn't 0. So the 4 is fine. Everybody good with that? However, if I take the -2 and I go and I plug that back in to x plus 2, that gives me a 0, right? So that tells me this solution is extraneous. So my only answer is x equals 4. Did that do it for you, Reese? Sorry for stumbling a little bit through the setup of that problem, but those are tricky to come up with off the top of your head. But we got it. Emma?
You said if like you plug them in and one of them equals 0, then it's the other one?
If you get a 0 denominator, that solution is extraneous, so you discard it. And if you have another solution left that doesn't give you a 0 denominator, then that's your answer. If there's nothing left, because you discarded all of them, then there's just no solution. But it doesn't mean just because it didn't work for one, it will work for the other. I mean, they could both fail. Lily? You could use the quadratic formula, right? If you wanted to do that, you could have still done that, and that would be okay. Again, the quadratic formula always works for a quadratic, so you can always use that tool. Just this one, I tried to set something up where I could factor it since I needed something factorable to get an extraneous solution for the denominators I had, which were factors. So I just had to do it that way. But you could have used the quadratic formula on that and still gotten the same answers of 4 and -2. And I think we programmed that in our calculator, didn't we, at one point? So you can still use that program there to get those things. Okay. Emma. Sure. So let's just say that we have 12x squared plus 36x over 2x squared plus 4x plus 2 divided by 6x squared minus 54 over x squared minus 2x minus 3. I think this will get lots of stuff to happen. Okay. So I would start by factoring. Actually, let's start by turning it into a multiplication problem, and then we'll factor. And Emma, if it's okay with you, I'll kind of do those both at the same step. So when turning it into a multiplication problem, basically all that's happening is this is flipping upside down. So I'm just going to, as I'm factoring it, I'm just going to do the flip while I'm factoring. Is that okay with you? Okay. So if I look at the first numerator, 12x squared plus 36x, I notice there's a greatest common factor of 12x. When I take that out, I'm left with x plus 3. Is that okay? In the denominator, I notice that I have a greatest common factor of 2. So 2x squared plus 4x plus 2 becomes 2 parentheses x squared plus 2x plus 1. And I notice that that factors numbers multiply to give me 1 and add to give me 2, or just 1 and 1. And then I'm going to factor the 6x squared minus 54. I notice there's a greatest common factor of 6 there. And then the x squared minus 9 is a difference of 2 squares. Minus 3x plus 3. And I went ahead and wrote that in the denominator, remember, because we're flipping at the same time. Is that okay? You sure? Go ahead. So remember, this fraction being flipped. Yep. Again, if you need to do that in more than one step, like go for it, do it more than one step. I'm just kind of doing it at the same time, just to reduce the amount of writing I have to do. But that's all that's happening there. And then the x squared minus 2x minus 3, that factors the two things that multiply to give us negative 3 and add to give us negative 2, or negative 3 and positive 1. And now it's time to reduce. So I notice that the x minus 3's can cancel. This 2 can cancel with the 12 to turn that into a 6. This x plus 3 can cancel with that x plus 3. This x plus 1 can cancel with that x plus 1. And this factor of 6 can cancel with that 6. So the only things left is these over the x plus 1. So that's my answer. Emma, are you okay there?
Yeah.
Okay. Gabby?
How would you do that if it if the top numerator was just like 3? Like, you know what I mean? In one of the questions, it's like there's only like the number 3 on the top and x on the top. Like, how would you do that?
I mean, it's just 3, it's 3.
Okay.
I don't know. Like, there's, you know, you can end up with just the number on top. That's okay. Or if there's nothing if there's just like the one of the numerators is just like a 3, that's fine. There's nothing to factor, you know. You might be able to reduce it with the greatest common factor from something else later on in the problem, but there's not much to do there. Is that
yeah,
answer?
but like what if like before we get to that like end, like what if like the beginning of the equation like it was just like 3 over.
So the problem starts like this. That's fine. You can just have a 3 up there.
Okay,
Nothing.
Okay.
Yeah.
Okay.
I mean, if this thing, then you're able to factor like a 6 out or something later on. You can reduce like a greatest common factor somewhere, but there's no factoring to do with it. There's nothing special you need to do with it. Is that?
Yeah.
Okay. So we've done a graphing one. We did a solving one with an extraneous solution. We did a multiplication division one. The multiplication problem is ostensibly the same problem, right? Just you don't have to do any flipping for that one. What else do you guys want to look at? We can do more of something else, or we can do another type of problem. You guys tell me. I know what I'm doing, so I'm just trying to help you guys out. Landon? Sure. Do you want to do like a proportion, or do you want to do the same kind of one that we just looked at? Okay. Let's just do a proportion then, just for the variety's sake. So this is the proportion, right? So to solve this, we're just going to cross multiply. Well, first you should probably check to see if there's any reducing you could do, but nothing is factorable, so I'm going to go straight into cross multiply. I guess I should at least make mention of that. I think on the review or something, there's a problem where if you didn't reduce before you cross multiplied, it was pretty terrible. But if you did do the reducing first, it was pretty manageable. So that cross multiplying just gets rid of fractions and turns that problem with fractions into this problem with no fractions, which is nice, right? No fractions. So to solve this is a polynomial equation. I got to FOIL everything out and then get everything onto one side, and then we'll see what we can do. So here we have x squared plus 5x plus, and over here we have 2x squared plus 3x plus 5. And then I'm going to move everything onto the right-hand side, because if I move it onto the right-hand side, my x squared term will be positive still. And that just makes everything a little bit easier if I might have to factor. But it doesn't really matter. It wouldn't be wrong to move everything to the other side, but that's not what I want to do. And at this point, I'm left with a quadratic equation. This quadratic equation I could either solve, or I could try solving this by factoring, but it doesn't, right? There's not two things that multiply to give us -1 and add to give us -2. So I must use the quadratic formula. So -b plus or minus the square root of b squared minus 4ac all over 2 times a. So negative of a negative is positive. 2 squared is 4. And then 4 times 1 times -1 is -4. So I have 4 minus a -4, which is 8 over 2. And this answer would be fine for me, or you could keep going, and there's some simplifying you could do. But that answer, the way it is fine. You don't have to reduce that anymore if you don't want to. You can certainly try, though. If you're taking an ACT or whatever, they would reduce it a little more and would end up being turning into that, but you don't need to go that far if you don't want to. Landon, does that feel any better? Yeah. Keep in mind here at this step, when we get everything onto one side, you don't necessarily have to end up with a quadratic, right? You could end up with a linear equation where there's no x squareds left, in which case it's just like an algebra 1 problem, right? You just move the constant to the other side and divide by the coefficient. Is that okay? I think that happened a couple of times on the review as well, right? They don't always have to be quadratics. Emma, is your hand up, or are you just resting? Okay, go ahead.
How did you get the 5x minus 6? Like, how did you get, what did you do with the...
So I'm FOILing, so I did x times x, and then x times 2, and then 3 times x, and then 3 times 2. And when I combine that all together, that's how I got the 5x and the plus 6 there. So I just didn't show the work for the foiling. I just did it in my head. Again, if you need to write it out, no big deal. You don't have to do anything in your head. If it's easier for you to write it down, totally understandable. Write it down, no big deal. But I think this is probably a good place to stop here, right? So I'm going to grab your tests and pass these back and let you guys take another pass through. Again, you don't have to change anything if you don't want to, but you do need to at least look at it and flip through and make sure that, like, you look at your problems and look at your work and that you've done things correctly. The best of your abilities. Maybe it's perfect already. I don't know. Actually, not. Well, then I would suggest thinking about changes. Oh, okay. You were gone. That makes more sense. So obviously you're going to do yours on the tablet update. So again, if you're stuck on something and you want to ask some questions about it, feel free. That's totally fine. Also, just as a reminder on number 3, we changed that plus 15 to a minus 15 in the numerator of the second fraction on number 3. We announced that in class. I just want to make sure I announce it again.
All our stuff is in
Yeah, do you want to go back to the media center?
Yeah.
And then when you're finished, you can bring it back?
All right.
Yeah, that's totally fine.
Are we? So what are we doing with this? Just correcting?
You can change anything you want on it, but we've given you some more time to work on things. We've gone through some examples here in class.
All right.
So if you want to go and to do that, you can go and do some more work and come back.
All right.
We were walking over when you talked about the beginning, like these ones, the
Okay.
ones. Was that recorded by chance?
Yes, I am recording it right now, but it will not end up